Hey, welcome to Physics 1403, Stars and Galaxies. This video I want to discuss two things. I want to discuss the death of small stars and the death of intermediate sized stars. All right, so small stars first. And by small stars, I'm talking about stars that have a mass between 0.8 solar masses and about zero point 0.4 solar masses. All right, so we're talking red dwarfs, basically. These are stars that are comprised of not a lot of matter, not a lot of hydrogen, and they're not particularly hot, all right, which is why they have a reddish color to them. They're also not particularly luminous because they're small, in addition to having that cooler surface. And the thing is that inside of this red dwarf, there's this constant convection between the surface and the core of this red dwarf. So as a result, as hydrogen is fused into helium, helium is never going to have an opportunity to really accumulate in the core. So essentially what's going to happen is over the course of 100 billion years or so, a red dwarf is going to use up all of its hydrogen reserves. And it'll be essentially a big, well, big compared to us, small compared to other stars. All right. But it's going to be a big ball of helium, at which point it doesn't have enough mass to do anything else. And so it's just going to then fade away. And what that fade away looks like is anybody's guess. All right, probably just going to cool off. It'll contract, but it doesn't even have enough mass to become a white dwarf. And so it'll just kind of fade away and be a ball, and then probably eventually that helium will rejoin the interstellar medium or something like this. Now, a medium mass star, so think zero point 0.4 solar masses up to about 8 solar masses. Okay, so this is an intermediate mass star, and most of them are going to have, when they're on the main sequence, they're going to kind of have a yellowish look because of their surface temperatures. And so what's happening here is, as I've described in another video, is that the helium is going to accumulate in the core of that star. And then as it does so, hydrogen fusion will stop temporarily in the core, and the core is going to then contract. And as it contracts, it's going to heat up from, say, 15 million to 100 million Kelvin. And as it heats up, then it's going to take that helium and it's going to begin to fuse that helium and go into, I call this, and I've said this several times, it's midlife crisis. It's going to leave the main sequence. Red dwarfs never leave the main sequence. They stay on the main sequence from birth to death. Okay? But these yellow stars, these medium mass stars, they're going to leave that main sequence and become red giants, and then they're going to become asymptotic gas branch giants. All right. And at each of these stages, what's happening is, again, they're going through this hydrogen. This core is, we'll edit some of this out. I'm going to start over a little bit, okay? So, all right. So as the core condenses, it heats up, and then helium fusion begins. And then as helium fusion goes on, it reignites some of the hydrogen that's in a shell. This is what causes them, remember, to get so big. That's where they become these red giants and then these asymptotic gas branch stars, is because that shell fusion is pushing it out. Well, now in a lighter star, say between 0.4 and 4 solar masses, the helium is going to fuse to make carbon. And then they're going to end up with this carbon core. If it's larger than that, say between 4 and 8, then in addition to carbon, it'll also form some other metals like sodium and magnesium and neon and oxygen. And so there's a little bit more variety in there. Plus, it's also going to produce a lot of free neutrons for neutron capture so that we can have some isotopes of those materials. But either way, that's it. After carbon, they're done. They don't have enough mass to have an internal temperature enough to go any further. So the core is going to continue, it's going to collapse when they run out of carbon, when they run out of helium fuel, and then they're going to have this central mass of basically a white dwarf. And this white dwarf is not actually a star anymore. It's actually the corpse of a star, essentially. It's the burning ember of the star. It is incredibly hot, and it is incredibly luminous, but it's not particularly bright. And the reason they're not particularly bright to us is because they are so small. But they are very hot, and as they burn through all of that, well, they're not burning through fuel, they're just slowly cooling down. All right, all the heat is from the compression from gravity. Gravity is actually providing the energy for that heat. And then essentially what's going to happen is after billions of years, that white dwarf will cool enough to form what some astronomers refer to as a black dwarf. But a black dwarf has never been observed. That is just a hypothetical right now, is that a black dwarf is just the cooled off remains of a white dwarf. A big chunk of carbon, maybe carbon and oxygen and neon and some of these other things in there. But either way, for the intermediate medium-sized star, we're done. We're done, and they're going to fade relatively peacefully into the night sky. Our next video, these guys will not be fading peacefully. And so that's going to be our next video. So until then, you have a great day, and I'll talk to you later.